Welcome to the Math Record. Today I'll be introducing the concept of the integral. So first off, what is the integral? Well, basically, the integral is just the reverse derivative, or what is commonly known as the antiderivative. So the derivative, which works from the original function to a derivative. The integral, which is like a really long s, works from the derivative to the original function. So it's just a reverse idea. So it's just basically going backwards. That's why it's like in reverse. So let's understand this with an example. So let's say f of x is equal to x squared. So what function, when we take the derivative of that, would give us x squared? Well, we have to think about in reverse. When we're dealing with polynomials, we're doing the power rule. So what's the reverse power rule? Well, basically, instead of subtracting 1, we add 1. So 2 plus 1 is 3. What's the derivative of x cubed? That's 3x squared. Well, that's not the same as this. So how do we get it to be the same? Well, we just need to scale 3 to a 1, so multiply by 1/3. The derivative of 1/3 x cubed is 1/3 times 3x squared, which is x squared, which is how we find it. So that's basically the like a basic example of an integral, and we could denote that by capital F, and that's going to be our integral. So a way to write this would be the integral of f of x in respect to dx is equal to capital F, and that's basically it. So why do we write in respect to x? Well, similar to how this is our derivative, this is just a simplified form for saying d of dx of f of x. Well, this would just be a complete form to write our integral. So we know it's in respect to x, similar to how a derivative have in respect to x. So this will tell us what we're taking the integral in respect of. Because later on, when we're working with some other stuff, this this could change. Okay, and earlier in this series, I said that the integral calculates for area under a curve. This property has a unique name. It's actually called the fundamental theorem. So fundamental theorem of calculus. And it's basically using an idea, as I said before, that the integral of f of x of dx, if you take it from values from a to b, it's going to be equal to the our integral, that integral function from b minus f of a. And that's the fundamental theorem of calculus. So it just relates the idea of our derivative to our integral. So what's the difference between this and this? Well, this is just the general form. This is when we need to calculate some values, basically. So when we're calculating for area, we're gonna use this. They're both the same thing, it's just that one of them have numbers so you could find a value, a specific value. Similar to how we have a specific equation for the derivative, like let's say we have f of x is equal to x squared and the derivative is 2x. This is the general equation of the derivative, but when we find a specific derivative at 2, this is like the version of this, while this is the version without the numbers, basically. So the general form versus a specific value. Okay, so let's use that to find the area under a curve. So using our example again, f of x is equal to x squared, and we set our integral was equal to 1/3 x cubed. Now, if we want to find the area under x of x squared from x equals 1 to like x equals 2, using the fundamental idea of fundamental theorem of calculus, we have from 1 to 2, and then x squared dx is equal to f of 2 minus f of 1. So what's f of 2? We'll plug in 2 into the equation. So that is 8/3 minus plug in 1 into the equation. That's 1/3. And that equals 7/3. That means the area under this curve is 7/3. So how this looks would be this parabola at x equals 1 and at x equals 2. the area, let's just draw the lines up to the curve. This area is 7/3, which I think is a really cool property. Well, that was pretty simple. But what happens if our equation wasn't as simple as like x squared? Well, basically, that's what we're going to be covering in our in chapter 3. We're going to be finding different ways to integrate if the equation is a lot more difficult. Well, that covers the introduction to integration, and I'll see you at the next video.